Hello and welcome to Web Math Academy. Today we're going to extend our discussion of complex numbers, expanding on last week's lesson where we used complex numbers in rectangular coordinates using addition, subtraction, multiplication, division. Today we're going to discuss polar coordinates, in which it is much easier to multiply and divide. If you remember from last week, if we plot the complex numbers on the xy plane, using the x-axis as the real axis and using the y-axis as the imaginary axis, we see that we can also refer to the numbers in polar coordinates with variables r and theta. Here r, called the modulus, equals the magnitude of the vector x plus yi, and theta is called the argument of the complex number, so that we have the following equations. X equals r cosine theta, y equals r sine theta, and then using the Pythagorean theorem, r squared equals x squared plus y squared, and tangent theta simply equals y over x. So we end up with x plus yi equals r cosine theta plus I sine theta. This is the formula that relates rectangular coordinates to polar coordinates. Now we can rearrange for r and theta, and we get the equations r equals the square root of x squared plus y squared, and theta equals the inverse tangent of y over x. So let's use our complex number example from last week's tutorial to derive its polar coordinates. Remember that we had x plus yi equals 3 plus 4i, where x equals 3 and y equals 4. Substituting 3 for x and 4 for y gives the following. R equals the square root of 3 squared plus 4 squared equals the square root of 9 plus 16 equals the square root of 25, which simply equals 5. And theta, equaling the inverse tangent of 4 divided by 3, equals 53.13 degrees. So our result, r cosine theta plus I sine theta, equals 5 cosine 53.13 degrees plus I sine 53.13 degrees. And even easier, we can use a convenient shorthand, which simply relates the r value of r equals 5 and the theta value of 53.13 degrees. So this is the simplified form of the polar coordinates, and that's what we'll use from here on out. You might also want to try our other complex number from last week, which you might remember is 5 minus 2i, and that can be represented by 5.385, 338.2 degrees. If the vector is located in a different quadrant, you might need to adjust the theta from the appropriate axis to get the correct angle. For example, for our 3 plus 4i in quadrant 1, there is no change needed. But if we had negative 3 minus 4i, that would be in quadrant 3, you notice that negative 3 plus 4i gives the same theta, 53.13 degrees. That's the same as we had in quadrant 1. And a calculator doesn't know that you're in quadrant 3, so you have to remember to add 180 degrees to it. You can refer back to this table at any time, knowing which quadrant you're in and whether or not you have to add or subtract to get the appropriate angle. As I mentioned, it's much easier to multiply and divide complex numbers in polar form. The formulas are simply as follows. For multiplication, the magnitudes are multiplied and the angles are added, so that r1 theta 1 times r2 theta 2 simply equals r1 r2 times the quantity theta 1 plus theta 2. In division, just as simple as the multiplication. The magnitudes are divided and the angles are subtracted. So here we have r1 over r2 and the theta 1 minus theta 2. So let's do an example. Let's say that our r1 theta 1 is 5.1, 21.3 degrees, and r2 theta 2 equals 2.6 times 196.2. I'm sorry, 2.6 times 196, 2.6, 196.2 degrees for theta. If we multiply those, 5.1, 21.3, 2.6, 196.2, and we just use our formula up above, we come up with a total of 13.26, 217.5 degrees. And you can verify that yourself, and we're also going to use the TI-Nspire calculator to find another way to get that same answer. For division, 5.1, 21.3 divided by 2.6, 196.2 degrees. we divide our values of our 5.1 divided by 2.6, subtract the angles, and we get 1.96 negative 174.9 degrees. Now, in some applications for complex numbers, we really want that to be a negative number. However, for our purposes, we're going to make it into a number between 0 and 360. And to do that, we're just going to add 360 to get the final result of 1.96, 185.1 degrees. So going over to our TI-Nspire calculator, there are a few kind of quirks with it that you should know. Let's go ahead and add calculator document here. The first thing you should take a look at is whether this is degrees or radians. For our purposes, we want to use degrees. Otherwise, it's going to give you everything in radians, which is not the easiest for polar coordinates. So let's try with something simple, and we'll just convert a polar coordinates to rectangular coordinates. And let's use our example 1 over here, our value of 5.1 with a theta of 21.3. The calculator is very easy. All we have to do is type it in, hit enter, and it'll automatically give us the rectangular coordinates value. So we'll type in 5.1, and then the divider between the modulus and the argument can be found by control, hit this book button, and you'll see it's right here. And just type that in, there it is, and then we'll put in the theta of 21.3. And there is a symbol for degrees that you can type in if you want, but it is not necessary. The calculator automatically knows that you're talking about polar coordinates here. Okay, so enter, and there's the syntax. Here's the reason why. One of the things with the TI-Nspire calculator is that it wants you to have parentheses around the value. So we'll just go ahead and put it in our parentheses and hit enter again, and there we go. There is our value in rectangular coordinates, 4.75 plus 1.85i. Now let's say we want to convert that back to polar coordinates. Again, very simple. Go to the menu, number 2, number 9, complex number tools, and convert to polar, and enter. And it takes it out to 13 decimal places in case you need that much precision, and it gives us back our answer 5.1, 21.3 degrees. So you can see that converting isn't that difficult. Now let's try some multiplication. Here's the deal with multiplication. For some reason, I'm not sure why, when you multiply in polar coordinates, it gives you the answer in rectangular coordinates. So you actually have to take a second step to convert back to polar. So if we enter in with parentheses 5.1 and then control book to get the divider in there, and 21.3, and that would be times 2.6 196.2, right parenthesis, enter, and there you see it gives the answer in rectangular coordinates. Again, very easy to switch to polar. And to do that is very simple. Hit control and answer, then go to menu, number, complex number tools, convert to polar, and enter. And there it is, 13.26, and it gives it in the negative 142.5 degrees. You see we have over here, we have 13.26, that's exact. And then our answer, you would get if you added 360 to 142.5 negative, that'll give you 217.5. Division is done the same way. I invite you to try it, and you'll see that you'll get the exact answer we have over here, 1.96, 185.1 degrees. We thank you for watching our tutorial today. We hope you found it useful. If you have any comments or questions, you can leave them at our website, webmathacademy.com or eurekamathacademy.com. Thanks.